everybody. My name is Reut. Good morning. I was invited to give an update in a presentation about the Israeli Mars Society chapter and about the DMARS, the Desert Mars Analog Remote Station project. First of all, I would like to deeply thank the organizers of the 22nd Annual International Mars Society Convention at the University of Southern California, not only for inviting me, but also for providing absolutely excellent webcasting capabilities. We are a global movement, and having these capabilities in such an excellent quality, I've been able to follow through the different panels and sessions, and it's been fascinating. So thank you very much for the organizers. Thank you. So in the short time that I have, I will introduce my activities in the last 2 years via the Israeli Mars Society. So who am I? My name is Reut. I have a PhD in microbiology and immunology. I'm an astrobiologist. I like to look at extremophiles as well, and also at forward and backward contaminations issues with a human crew in an isolated environment. I work as a research associate at the Dead Sea Araba Science Center in Ramon in the Negev, in the south of Israel. I'm also the co-founder of the Israeli Mars Society in 2017. And I'm also a co-founder of another nonprofit organization called DMARS, which I will explain more later on in this presentation. The Israeli Mars Society was founded by these magnificent individuals from left to right. We have Yoav Lanzman, who is the Space AL Chief System Engineer of the Bereshit project. We have a space education specialist, Miss Moore Langer-Apple, who also works with Keren Ramon and many high schools in Israel in that area. We have an aerospace engineer, Miss Vera Gutman, and I have a meteorologist by the name of Miss Maya Barbo. And these are, together with me, the co-founders of the Israeli Mars Society. They are all alumni of the International Space University. I've been a core lecturer for astrobiology at the summer space study program that they have every summer since 2016. And I've been very familiar with that organization and its projects. The Israeli Mars Society, the topics for today will include a short background on what is the motivation behind our activity, who we are, what do we do, how do we promote science, how do we promote STEAM projects, and if I have time, I will talk more about the challenges and future prospects of the Israeli Mars Society and also DMARS. The Israeli Mars Society is very much about connecting people to the Mars future that we all want to. It's very clear why we want to go to space now. It's very clear why we should do it now, in my opinion, and for the crowd now watching me talk. But the question arises, why specifically Israel? And in my mind, when I co-founded the Israeli Mars Society, it was because of two main themes. One was the desert theme. Half of the country is desert. We're very well equipped, and we have a long history of living in the desert and working and living off the land, and using sometimes sophisticated solutions for it, sometimes less sophisticated. And the second thing is that we are very much an innovative country. And Israel has many different types of technologies which are absolutely essentials for a successful space settlement. And we're very eager to promote those and bring those technologies and that knowledge to new space, commercial space and new space projects. So in order to, because they say one picture is worth 1,000 words, I have here a very nice collage of 7 pictures. And if I were there, I would usually ask you to shout out which picture you think is from Earth and which picture is from Mars. Roy Noor, a PhD student who did this, has generously offered me this slide. And I'm gonna leave me hanging there for a while, but I'm just gonna let you know that from these pictures, 2 pictures are from Earth. And if anybody wants to shout out, feel free to shout out which one is from Earth in your opinion.
One person said 4. Well, 7. 4 and 7.
Okay.
5.
So
5. 4, 7, 5.
Okay, so 2 are wrong and 1 is correct.
Which one?
You see, it even works across Atlantic Ocean. So actually the pictures from Earth are number 2 and number 7.
Number 2 and number 7 from Earth. Okay. Well, they're darker colors, so maybe that might be a clue. The other ones seem to be all the same color, but. Yeah.
And all these come from a beautiful town called Ramon, who has the Ramon Crater. And the Ramon Crater is an erosion type of crater. It's an international well-known geopark. It has layers for going back 250 million years. It has magmatic rocks. It has volcanoes, volcanic rocks. It has clay, some type of morphology which is very much similar to Mars, and we thought it would be a smashing idea to do analog missions there and promote the public awareness to what it means to live on Mars. And that town is becoming more and more connected with different space projects, not just our own, but Israel as a whole is now getting more into space and spacey things, which is awesome. The Desert Mars Analog Ramon Station was founded in the late 2018, but actually already started its roots into the end of 2017. And our mission goal in this NGO is to be a significant partner in the first manned mission to Mars, and that Israel is the nation that can lead that mission, a very ambitious goal. At the moment, we're working along very different vectors in order to achieve that. What you see here is a drone view taken by Professor Alonso during the first Mars simulation experiment that they had in 2018. Since then, we have 8 more missions, some of them as short as 2 days, and the longest one was 11 days, and it's going to be presented at the IAC in the IAC conference actually this weekend as well. And what we found out is that this kind of a project is very inspiring for people. Instead of just talking in conferences and saying why we need to go to Mars, all of a sudden you have a habitat, and you have a crew, and you have a rover, and you have problems that you have to solve, and it becomes very, very personal. So we aspire to build a space simulation center, and we're already in the works. So it's sort of like a grassroots movement that works from bottom to up. It's a dream come true. We had 2 architects and space architects to work on the first habitat, which we call Hub 01. And the general idea was that we're going to have 1 subunit and eventually 6 subunits that will turn into a shape of a star, a dated star even. And then you will have much more room for people to have different functionalities in different subunits. This is the internal diagram of the new habitat of DMARS, of Hub 01, which is currently in the field and is going to be used next year as well in our missions. And what you have here different sections. So starting from the north and going clockwise, you have the hatch where people would wear on and off their spacesuits. You have a small space for the control room. We do a simulation, we do it with a 10-minute delay to each direction. So we'll simulate, of course, the communication delay that's going to be between Mars and the mission support crew. We have pods, sleeping pods. We have a small unit, small kitchen, a small bathroom, no showers, place for the kitchen and crew to settle around, and also a very small area on the left of the habitat for some lab equipment. It's a very spacious design, and 6 people live in it very, very comfortably. Here are some indoors pictures. I have many, many pictures. I will show only a few. What you see on the right is that you see the sleeping pods. They're actually very, very spacious. They're very long inside. And because they're made out of wood, they're very pleasant to sleep in. What I really like is that the walls of this habitat are opaque, which allows a lot of light to come in, but not too much. And you're also very much aware of the light cycle, of the light cycle day and night, which is very important for psychology, as we all know. On the left, we see the crew just coming back after doffing some of their spacesuits. Our spacesuits were designed by Alon Livne, who is a very well-known Israeli designer, who also apparently did some of Beyonce dresses. So I was feeling very lucky to wear one of his spacesuits. We aimed to do a few things with these spacesuits. We aim to mimic the isolation and some of the physical burdens that you have when you have in a spacesuit, when you're going out on a mission. these spacesuits, once you have the PLSS and the helmets on, the total thing is about, I would say about 15, 13 kilos, about 30 pounds. Walking around 4 hours with them is pretty heavy. They have a bit of air conditioning inside, not a lot. And they're very, very, how should I say it? They're very robust. And they have been very successful in our work outside. So an example of an analog mission, very briefly, about 4 or 5 days. So about a year before the analog mission of the 5 days, we go out and we offer people from the general public to be aeronauts. We do then a very extensive interviews, followed by some field work and some group dynamics in order to make sure that we have the right people for the 6-people crew. We are very much aware that we want women, and we do affirming action to get more women into the crew and make sure that the crew is well adjusted. We're also very much open to people coming from other places in Israel, whether it's from the north, whether it's from the south, not necessarily from people who actually live around the R&D center in the center of Israel. And we also start collecting. We start with volunteers who help us a lot during the mission, doing mission support center. We have a lot of shifts that they have to be filled during the mission, and each one is getting, we do training in order to explain to them different functionalities and roles of these people during a analog mission. For instance, you have the commander, you have the CAPCOM, you have the flight director, of course, you have a science officer, you have doctors as well, taking care of the crew from remotely, and so on and so. During about half a year before the mission starts, the science team is already pretty sure about which science experiments are going to go inside the mission and starts training the Ramonauts as best as we can for that time frame. We are very much aware about OH&S issues. We're very much aware about the capabilities. And some of the experiments, even though they are super relevant for a Mars mission, are not going to be accepted if we think it's over the capabilities of our volunteers, basically. It's important to say that this organization at the moment is completely on a volunteer basis. So for instance, if we're looking at the scientific data pool for 2018 and 2019, I was the chief scientist for these, for all the missions during 2018 and 19. I have a crew of 6 volunteers, mostly PhD students and master students from different universities in Israel, who are very happy to put their non-existing spare time into this project and work with me with researchers all over the world. So basically what we had so far, we had a total number of 14 experiments. We had 18 Ramonauts that performed these experiments, which is very important because some of these Ramonauts don't have any scientific background, but they do have an engineering background. The number of organizations that submitted research proposals is now 16, and we're talking internationally as well as nationally. So we had proposals submitted from Ben-Gurion University, the Hebrew University, the Weizmann Institute, several research centers in Israel, and also we have, for instance, from Palo Alto University and Stanford. The research subject, the research categories by now that we have are 8. We'll show them later in a slide or two. And in order to make a mission work per year, we need a total number of about 100 volunteers, because this mission requires also people who know about architects, and we need people to help us with communication, with electricity, with all the infrastructure. It's quite a lot of volunteers, aside from just doing the day-to-day mission control when you have a mission going. My volunteers in the science teams are 7, and I found out that on average, it doesn't matter which type of mission do we have, whether it's a short mission, whether it's a medical-centered mission, whether it's a science mission, we're usually able to perform up to only 3 experiments per 1 mission day, when a mission day starts at 6 a.m. and we end it officially at 5:30 p.m. every day. So 3 experiments are what we are capable now to support. To give you some photographic examples of what kind of science we do, excuse me, we do a lot of soil analysis, microbiome analysis, On the left side, bottom pictures, what you're seeing is you're seeing our Ramonauts, Dr. Hillel Rubinstein and Jackie Fay, opening basically a hardened case which enclosed a mobile detector for muon particles, made by Professor Guy Ron from the Hebrew University. And we were doing situational awareness because at that time of that specific mission, DMARS 01, there was an additional crew with a similar case in Oman with the Austrian Space Forum, and they were doing the same type of measurements when we were doing it. So basically we had here two different organizations working together in an analog mission across planet Earth, mimicking exactly how two teams of astronauts on Mars would probably go and do some physical measurements of the environment. In this case, it was how many particles and muons going through the atmosphere per hour, things like that. On the right side, you see my colleague and dear friend, PhD student Yair Hellman, and she was swabbing gloves. And one of the things we're looking now and we're waiting for the results is to see when you have a long-term mission, how much of the outside bacteria goes into the habitat and how much bacteria from inside the habitat goes outside. Is there some sort of a mixing of population? Is it dangerous, not dangerous? What is the taxonomy of these bacteria, and so on and so forth? We did a short mission by medical, which was involved by specialists from the ER, I think in Ichilov Hospital, and also other people. What we were doing was that we were establishing how to help a Ramonaut, someone with spacesuits on and a lot of things, and something bad happens. How do you communicate? What do you photograph? Can you use the rover? We had a very stupid yet mobile rover to do these things. And how much equipment can that rover bring over to the astronauts? And they had a lot of things additionally, such as teaching non-medical students inside the habitat how to use a drip, how to use different things. And there's a lot of potential there in the medical area, and we're working on additional missions with medics, basically, to also look into remote operations from the mission support with the time delay and so on and so forth. So some of the science research missions that we have in the DMARS in analog missions in Israel and with Ramon is that we had things related to nuclear physics, variations in cosmic ray flux, measurements at ground level. We had a preliminary work on 3D printing, operational workflow experiments for a crewed Mars expedition. Microbiology, we had an evaluation of microbial potential contamination, which was led by me and also other people. And we had evaluation of novel emergency evacuation using a mobile rover. Additionally, we had some analysis of microbial crust on rocks and soil. And some of these analysis, I have to say, you collect the samples, but you not necessarily go all the way with the analysis that you can, because our habitat at the moment does not include all the necessary equipment to do an in-depth molecular analysis or microscopy, for instance. From an operational point of view, we have some very interesting results regarding situational awareness training, aims to simulate 2 separate groups of astronauts on Mars, and also we had operationals about how to do EVA management. One of the things that I found out during this project is that a lot of people coming from special forces units have a lot of interesting military-based knowledge, which is actually very much relevant to how an isolated group of astronauts need to communicate with one another and need to understand what type of situation they are and how to respond to different emergency situations. In robotics, we had some interesting proposal, which did not mature into a full-fledged field expedition. And I was very sad about that, but we had some fantastic things going on, and we're going to try again with some of the robotic experts in Israel. So for instance, a suggestion by Professor Goran Gordon from the Tel Aviv University Curiosity Lab he suggested robot-digger swarm for Mars habitat. And his idea was to, with his PhD student, to supply us with a group of maybe 5 small robots, about, I would say, 1 to 2 kilos, which are completely from polymers made by 3D printing. And each one of these they have swarm capabilities, and each one of the robots can do a different functionality. And so one robot digger would do the digging, other would collect the soil, other would move it, one will be the communication base, one will provide some batteries, and so on and so forth. Another robotic experiment by NED, a company which designs a completely new type of neurological chip for running computational algorithms, has actually developed a rover that can do image mapping very, very quickly. We're talking about a rover that can go up to 20 kilometers per hour on a terrain that it's unrecognized to it, and do all the different navigational and different algorithm computation that needs to be done. Again, we found out that with these projects, adapting them to the field is sometimes too much for the technical team, and also the time, it's very hard to sync a mission, an analog mission preparations and procedures with the maturation time of a sophisticated technological project. But it's super interesting, and we're looking forward to other proposals in that area. From a psychological point of view, I'm never worried, there's always too many proposals in the psychological area. Psychologists really, really like to give us many suggestions on how to do experiments on our crew in an isolated environment. They love the setup, and we have very successful collaborations with the Italian Mars Society and with the Brazil Mars Society, and also other researchers who have submitted successful proposals. So we have said basically, let's build it and they will come. And this is just a fraction of the Ramonauts who have been participating in our mission since 2018. And each of these persons go back to their community, to their workplace, to their families, and they're an inspiration to anybody to do space. So some of these people are photographers, are musicians, are educators, are farmers, are biotech. We're not talking just really sophisticated engineer or the medical professional or things like that, but we really are open, and we are able to provide a real scenario of an isolated crew in a habitat on Mars in a unique area. We are able to provide that to a lot of people from different backgrounds, and that really excites me, actually. So I was doing a mission. I was a part of the crew of DMARS 01, the first ever. It was 4 days in Ramon. We had a very tight schedule. We had about, I think, 5 or 4 experiments that I had to do during those 4 days. And these are the things that I've been taught by these space simulation missions. And I was surprised, by the way, by how much it taught me. It's a very complex scenario. You work well with 5 other people. You really bump into limitations. How to do science, how to do proper science, how to do it with teamwork. A lot of things that have to do with the physical and mental endurance. Wearing the spacesuits, going out for 4 hours. Sometimes I had to go for an 8-hour actually mission, going back in, drinking a few things, drinking water, rehydrating, and going back out because the weather was turning bad. It could be a life-changing event. It's an isolated situation. It's very, very real. I had to learn very fast how to do the best communication skills I've ever had, how to fix things, how to coordinate my science project with other people in the team, how to explain some of my science to people who are from non-scientific background. That's actually really, really important. And I have to say that Machdesh Ramon, with its dramatic cliffs, its beautiful red hues, the volcanic rocks, the clay, everything, it's a really perfect Mars analog. You cannot wish for anything better. So Mars is actually closer than you think. And cheaper. So how do we do the funding and collaboration? The Israeli Mars Society is based on its members' fees, and I'm looking for new ways to get more funding for that. DMARS, you can see here the list of about 20+ companies. And also the Israeli Space Agency has been a generous contributor, and also ICA in Israel. These companies and organizations gave us a lot of expensive equipment and things to work with. We're, aside from the Israeli Space Agency, we were not directly funded by anyone at the moment. And because there has been some talks, and very interesting talks, by the way, about the STEM projects coming from the China Mars chapter, I wanted to introduce you to the Young Astronaut Academy, a project, a program, a year-and-a-half program for high school students, funded almost entirely by the Israeli Space Agency. And we were very successful now for 2.5 years to run 3 different classes from the Davidson Institute for Science and Education and the Weizmann Institute of Science. And this is an amazing program. Basically, we take 15-year-old boys and girls in a small group, and we teach them anything that an astronaut will have to know when they're going exploring the moon or a different planet. So we're very big on geology and planetary science, and microbiology, and astrobiology. But because we're doing it outside of the classroom, they do work a lot with their own limitations, their confidence, their skills, their belief sets. Are they good as a team? Are they not? We have to work as a team in order to be really good astronauts. And the peak of this program is to have a 3-day mission by themselves near in the habitat that you saw. And they set up their own experiments, and they have to deal with themselves. So basically, 15-year-old inside a closed habitat going out only on missions. During the program, we teach them a lot about basic and profound terminology relating to geology. How to know if this rock is sedimentary, how to know if this rock had water in the process of its forming. Is it how to look for lichens, how to look for cyanobacteria, how to use a microscope, how to use different types of microscope. They go through sometimes space medicine simulations, they go through robotics, through 3D printing. We had a lot of leeway in what we want to teach them, because we find out that you have to, it's a very diverse program, and the students are actually really thrilled about it, that they're going to be astronauts. And eventually, yes, they do wear the suits. They have to be physical fit to do their mission, and they get a unique one-in-a-lifetime opportunity, basically. When they go out, you know, there's no GPS on Mars, so they have to know the terrain better, they have to know how to map, they have to be responsible for themselves, for their teammates, for mission control. It's an amazing experiment and an experience for young adults in Israel. You see here, I heard it's a bit choppy, but I'm going to explain what's happening here. We have here 2 crewmates, Shalev and Iris, and they're donning on their spacesuits, and they need the help of their assistants. So we have 2 boys helping them, you know, asking the right questions, making sure that the equipment is working well, that they can connect back home when you go outside on Mars, and it's a very harsh environment. If your equipment is not working, you can die. They're taking this very seriously, okay? So we are very proud that part of DMARS is helping to transforming knowledge to a Martian reality in our daytime. They don't have to wait for another Israeli astronaut to come to NASA to go to the International Space Station. They can start learning right now, and it's super important for them. And how would this was part of the drill, is that while we, you see here the guide, Nadav Kushner, and one of the students, outside of the habitat, basically what happens is because they're a teenager and they're a bit more volatile and they're still not entirely mature. We have a lot of safety protocols in place, and one of them is that if we feel the need, they have to go solo on an EVA, in which they go outside and they speak to our guide, and we talk about what's happening, what's hard for them, how do they feel, who's annoying them, what's annoying them, how they're supposed to deal with it, how they can overcome their fears and their problems with in this really tight situation. And the reason, by the way, we also adult astronauts do this because it's very heavy, the backpack. And sometimes when you want to rest in a 4-hour EVA, then you sort of like lie down. So it's an interesting thing. On Mars, as opposed to the Moon, you're going to have gravity. So I'm guessing you're going to have similar issues there as well. So just to recap some of the topics I've been speaking today. So what is our motivation in the Israeli Mars Society? Is to connect Israeli innovation, our knowledge of the desert, and just bring the Israeli public to the awareness that Mars is much closer than it has been.
We have about 2 more minutes to wrap it up.
Okay, thank you. And so who are we and what we do, what kind of science and medical they do on DMARS, and so on and so forth. Some prospects in Israel coming up is that on the left side we have an MOU signed between the Israeli Space Agency and the Austrian Space Forum, and they're doing their next analog mission in 2020 in Ramon, also using our habitat, so we're very excited about that. The Israeli Mars Society has a very nice evening, which includes not only people from DMARS, but also International Space University alumni to speak about their achievements and what's going on in space. And I just wanted to say thank you very, very, very much again, and I'm open to questions. Thank you.
Thank you. Is there any questions to the audience? We've got a couple minutes here for questions. Any questions? Okay, if no further questions, we want to thank you very much for your presentation, and it's very nice to know that Israel is very active in the space program and going to Mars.
Yes, we are.